Hi,
Hello,
Rebecca.
this is Rebecca and Stu from the Unison team. We're super excited to be sharing an implementation with y'all. So hopefully everything looks good in the live stream. Please do give us a shout out either on Discord or in the chat if anything looks weird. But we're super excited. Today we're going to do an implementation of the matching brackets problem in the Unison track. And I think that's going to give us a lot of opportunities to go through the workflow of submitting an exercise and working locally with the UCM, and then also talk a little bit about abilities, which is an interesting Unison feature. So the first thing we want to do is walk through a Hello World and just make sure that people see what it's like working with the UCM and Exercism, because the transition point, we want to make sure people can submit their exercises. And then we'll go ahead and we'll pull down the matching brackets exercise. Sound good?
Right. So one of the reasons why Unison was including in the mind shifting May, of course, is that it is a very different language to work with. We don't work with, we don't store your source code in files. We store your source code in a SQLite database after it's been type checked. And so because of that, working with Unison is often asks you to kind of be a little bit uncomfortable with your normal tools, and so that's why I think we're gonna go through with a little extra detail how we work with Exorcism and Unison together. Right.
Yeah, that's a good thing to call out, Stu. So I'm going to go ahead and in this terminal download the Hello World track, and that's via the Exorcism CLI, and it's going to open up a folder here called Hello World. These two .u suffixed files are what the UCM is going to look for. And so what I need to do now is within this directory, I need to go down into the Hello World folder, and let's take a look. And inside this directory are the two Hello World files. And now that I have those in scope, I can run UCM. And what that is going to do is if I try and change something about this file, the UCM is going to be able to pick it up. So it's in that directory that I started the UCM. It's looking for those two .u suffix files. Because of some conventions with the UCM, we're actually going to create a namespace called Exercism to work in. Okay. And the first thing we need to do is we're probably going to want our standard library in order to accomplish these problems. So I'm going to fork the top level base directory or namespace into something called lib.base. So by convention in Unison, your dependencies go in a namespace called lib. It's just under the root of the project. So our project is called Exorcism, and here the namespace with our dependencies is then lib.base. So with that in mind, now we can take a look at this Hello World file. So if I go over here and I'm gonna make it not pass here. In the hello.u file, we've got this hello.hello function, and I'm going to go ahead and add it. And now within my Exorcism namespace, there's a sub namespace called hello. And we can see it's a term of type text. And if I want to view its source code in the code base, I can use the view command in the UCM, and you can see what the code base has recorded it as. So this is the current implementation of hello.hello.
And
So
so
let's say I want to
the interesting thing here
go
about
ahead, Stu.
Unison, and just if you haven't worked with Unison before, like we alluded to before, now we could just delete this and save the file, and we never need to save that text again. But in the terminal, the doesn't care. We can move on, and if we need to then go back and work with some after we've deleted the code, if we wanted to go ahead and re-edit it again, we simply just she could run. Could you type the edit command and we could bring it back in?
Yeah.
So anytime.
So I'm going to save hello.hello in the file, and now let's say I want to edit the term hello.hello. It's going to think for a second. And it opens it back up in the last touched.u suffix file. So here we can see what the code base thinks the current implementation of hello.hello is. But we also probably want to run our tests. So to do that, we're going to use the load command. And load takes a file. And we can see that this read the test.u file into scope and ran the hello.test.u function here, and it failed. So let's go back and edit our hello.u file and make it pass. So I'm going to save it. And now, because I've already added this term, I'm going to update it. And now, if I reload that test file, we see our test pass. And I can actually add those tests to the file, to this namespace as well. And now inside the hello namespace, there are 3 terms. 1 is our hello world function, and 2 are some tests. So that's what that looks like in terms of working locally within the UCM. At that point, we could go back and submit via the Exercism CLI, as long as we've saved this hello.u file, and that's done via your normal Exercism CLI commands. So that's what the hello world looks like. We're going to go ahead and I'm going to get the matching brackets problem down here locally. So I'm going back to the Exercism track, and I'm pulling that in. Okay, and to do that, I'm going back into my terminal, and I'm doing Exercism download the matching brackets problem for the Unison track. Great. So here in our file explorer, we've got a .u suffixed file, which contains the stubs. We can also take a quick look at what the tests look like. So we've got some expectations around things being paired. We can take a look at the instructions for the actual problem locally. So if you need a reminder, the goal with matching brackets is to evaluate if a string return contains matching brackets, and the brackets can be of different types. You can do open parens, open curly brace, open square brace, and so you just want to make sure that it's sort of a well-formed matched string. If it is matched, then you return true, and if it is mismatched, like there are two closed ones that are not paired with their open ones, you would return false. So that's the crux of the problem. For convenience, and because we think our ability is really cool in Unison, we provided the stubs for a stack ability. Because one of the sort of canonical ways that you can do bracket matching is with a stack. And the stack, or the ability syntax, looks a little bit like this. We've defined that this ability here is called stack. It is polymorphic.
Rebecca, will you pause for a second?
Yeah.
There is some kind of, you seem to have a bandwidth issue where apparently you sound like the woman from Portal.
I do? Like the cake is a lie?
I think so. Could you, do you have anything that might be a quick fix on your bandwidth? Do you have a roommate who's watching 3 Netflixes at the same time or something like that?
I don't, but I can turn off my phone Wi-Fi. Maybe would that help? Not that it's doing anything.
Or anything where you could limit your... Or should we have you turn your camera off?
Ooh, okay, I can do that, yeah. How do I do that?
See if that makes your audio better. Well, yeah, shut down unnecessary applications. If you could, yeah, it could be slowness on the computer side because it's doing a lot of things like
Okay.
compressing, recording, and
I have
streaming.
I have quit Slack. Is it potentially
Just anything that's using a lot
Chrome
of
being
memory.
a memory hog?
Yes. Hmm.
Okay. I shut down just about every Chrome browser that I don't need. So, cool.
All right, we'll plow
Do
on
I
for a little
sound any
bit, and then
better?
I don't know. Let's plow on for a little bit and see what the chat says. I'll be watching the chat.
Okay, cool. Excellent. So, we were going to talk about stacks and abilities because this problem lends itself to an ability-based stack implementation. So, if you haven't heard of Unison's abilities, in the literature they're called algebraic effects, but we call them abilities. And they're one of the ways that Unison represents functional effects. And what that means is that you can do things like mutate state or write to a file or write to a database, but in a way that is functional and safe. So the abilities are represented in the type signatures of your function, and they're a way that you can provide behavior to a set of operations that you want to represent. Yeah, Stu, go ahead.
Let's try losing the video.
Okay. How do I do that?
You should have a camera. I don't know. I'm a different client than you.
Let's see.
We lost the screen, not the video.
Oh,
While she's doing that,
how to
I guess
turn it
we'll
up.
talk about outbreak effects. Well, we lost the screen though. Again.
Oh, sorry. Technical difficulties. Thanks for your patience. There we go. You see it?
Yeah. Are you gonna try and lose your camera still, or
Yeah, I'm going to try and turn it off.
okay? But so if you see on in her screen, the algebra, we have an ability here which represents a stack, and an ability is just provides um, a few terms. Think of them like functions, though some of the functions can have no arguments. So this ability stack provides four operations. You can push some type of A to the stack. You can pop an item off a stack. You can peek at the item that's on the top of the stack if there is one, and you can ask if the stack is empty. So what this allows us to do is you can see that on line 7 here, the uh, the matching brackets .stack.run function. But the type signature there, which comes after the colon, shows that it's the tick notice just signifies that it's a delayed computation. But inside the braces there, it mentions stack A, and then says that it's a function. Uh, from it's a function that uses a stack and then takes an R to return an R. So what that means is that inside this function, anywhere we're inside this function that mentions stack in the abilities list, we're able to call any of these functions that are listed on the ability. And we don't have to pass the stack around, or we don't have to know about the implementation of the stack. They just kind of become magic functions that are in our environment that we're able to call. And this is kind of the way that Unison, being a pure functional language, is able to achieve some of the things that some other languages might do with like monadic effects. But anyway, let's move on to an implementation. How are we doing, Rebecca?
I think we're good. Hopefully,
Okay.
I don't sound like a robot.
We'll see,
Very
but let's
cool.
move on anyway. I think we should move on, and knowing that the
Yeah.
recording is going to be good in any case.
Yeah. Cool. Yeah. I feel like we could start with a handler implementation for the stack, and that may be a place to start because the behavior of the stack is independent of the problem that we're solving. You know, a stack
Right.
has a push, pop, and peek operation. So let's go ahead and write that. I'm going to open up
Okay.
this UCM again. Okay. So
Right. So
we
this
are
stack.run
going.
function. Sorry, I talked to incorrect. Now I see what this stack.run function. What it says it's going to do is it's going to take a thing which uses a stack to produce an R, and from that it's going to produce an R. So kind of what we're doing is we're taking something that needs the stack ability and we're kind of going to eliminate it. We're gonna handle the stack for this function. So the thing that used to need a stack ability to produce an R, we're going to handle, like I said, we're going to handle the stack part and then just return the R.
Yeah, awesome. So we'll call this, well, we're going to write a helper function and an inner function here in the handler. We'll call it stack handler. And I am fairly certain that this stack handler is going to need some notion of internal state here. And so I'm thinking ahead here, and I feel like Unison's list could be a really quick and easy data backing for a stack, and pushing something to the list would be consing something onto the head of the list, and removing something from the stack would be removing something from the head of the list, and then we can do peek by inspecting the head and checking if the list is empty and so forth. So
Great.
each of these ability operations, push, pop, peek, is going to get its own pattern match in this case statement that Stu is writing. And then from that, we'll provide behavior to the abstract interface that we've defined up here in terms of the ability. So that's what our handlers do, is they provide behavior to the interface that we described. And that
So the way
it's
that we're
really
going to do
great.
this is that we're going to write a pattern match that's going to match on all the possible things that could happen using our ability. So first thing I'm going to do is do the push handler. So the push handler, the way these pattern matches look is they always look. There's two things that could be. It could be one of our functions here. So here I have the push and then the argument A that it takes. And then they take the continuation, which is saying this is kind of like um, the place that called it. This is the place that called it, waiting to kind of get its thread back. So what you need to do is at the end of doing whatever you're going to do, because they called push, we need to hand control back to the person who called into our handler by passing their return argument. So the return argument that they're looking for is just a unit value. So we're going to say handle the rest of the continuation after we've given it its unit value. And the handler we're going to use to do that is the same handler we're using now, the stack handler. But in this case, what we're going to do is we're going to stick that A on front of our stack. Oops, that backwards.
No, that's correct.
Why is a squiggle there? Oh, we need to import the
It does
list.
not know which cons. Yeah, so pro tip, if you ever get confused which side the colon should be on for our little operators like this, the colon is on the side of the collection. So just remember, those two things match.
Oops.
Useful mnemonic.
Okay, so that's one handler done. Let's do the next. The next is
Awesome.
pop, which doesn't take any arguments, but they all take continuation. And so when we pop, all we're going to do is we have to take one item off the list, right? So the easiest way that's most familiar is pattern matching list. We'll match state with it's either going to be an empty list, and then we can well, let's get our new state is going to be if it was the empty list, we're going to return the empty list, and if it's some head on the front of some tail, we're going to
Return
just
the tail.
the tail's the new state. So now we can say handle the continuation, and this one again does not expect anything with stack handler new state.
Yeah. And you'll notice what Stu has done here is another syntax for pattern matching. So earlier we were using the cases syntax, and that is kind of a shorthand way of saying match state with blah, blah, blah. Cases, it infers the argument to it and enables you to just sort of shorthand elide over this match blah with syntax. It's just something that's a little syntactic sugar.
And so here I'm doing the peaks case, and so I'm just pattern matching on our state. If we have nothing there, we return a none. If we have something there, we return that we have some head. So what are we going to do? Well, so in the none case, we're going to say handle the continuation that's going to get none of the result with our stack. New state. And in the sum case, continuation gets oh, sorry, the new state is with the tail in here. So, right. So in each case, we are sticking with the tail of the list, which in the empty case is empty. Oh no, that's not true.
I think peak.
Right.
I think peak we could just call list.head.
You're right. You're totally right. No, you're totally right.
And then we don't need to change the underlying state of this
You're
stack.
totally right. I forgot. Peak does not change the underlying state. Thank you. So the continuation gets. Yeah. Cut the head of the list.
Awesome. Very cool. So this looks like a working handler to me. We could kind of give it a quick test here in a watch expression. I'll let Stu finish that up, but I'll write a little.
Go ahead and start writing the watch. You can start writing the watch expression for sure. Yeah.
Okay.
I don't remember what it is, but I know that this will work. So what she's doing is that she's writing anywhere in this file, you can make what she's an expression starting with that right hand arrow thing. And what you'll see in a second is that when we save the file, if the file type checks, then what we'll do is it'll evaluate any of those expressions and print them out. So it's kind of a way to do just kind of like you can kind of do little throwaway tests and stuff like that. And then once you get them working or doing what you want, you can turn them into real tests that you can save in your code base and then use later if you ever do a refactoring. So looks like we're going to first three things, we're going to peek, pop, peek, and make sure they match. Oh, I see.
Yeah, I'm writing this out longhand.
Sure.
3 prime. That says tree. 3 I can spell. Okay. And I need to give you an argument.
Yeah, one more.
There we go. This needs to be nat plus.
Cool.
Oh, right. So let's take a look. Does it work? I saving it. Oh, and this is something that's really easy to do. So I already had my Exercism UCM open, but it was still inspecting the Hello World folder. So I'm actually going to exit the UCM, and I'm going to move up one directory, and now I'm going to go back into the matching brackets because that is where my files are being located. Okay, now if I restart the UCM from within this folder, the changes to my matching brackets should show up. Okay, so let's take a look here. Hey, look at that. So our stack.run function kind of behaves as expected. We are pushing 1, 2, and 3 onto the stack. We're gonna take a look at 3, and then we pop something off, so 3 goes away, and now we're gonna take a look at 2. And 3 plus 2 is 5. So, awesome.
Great.
Handler looks like it is working. So, I'm going to go ahead and comment that part out. Or actually, I'm going to move this part where we were kind of playing with this under the fold, which is this 3 dashes in unison. And that's kind of a nice way we can keep some code around as we're temporarily working on things, but it doesn't get evaluated by the UCM. So it's under the fold, it's kind of ignored by the UCM.
Exactly.
Okay.
All right. Should we work on the next function?
I think so. I think so.
So this is check balance, and it's taking a list of characters, and it can use a stack and to produce a boolean to say whether or not the brackets are balanced. So
Yeah.
sounds like fold over the list.
Yeah, I think a fold left would be great.
We could either do a fold left, or we could use abort if we ever see a problem, and do a for each.
Oh, interesting. We
How
could,
about that?
yeah, we could show multiple abilities.
Yeah.
Let's do it. Let's go for it.
All right, so we're going to do a for each over the char lists. And over each one, that's going to take a function to do with each char. And what were we going to do? Or we can just, okay, so this is a good demonstration. Here I was going to write a function that takes a C, I'm trying to autocomplete stuff for me, and does some stuff with C. But I think what I would want to do is pattern match on it. So this is kind of a good demonstration of what cases actually means. Cases actually makes a pattern match into a function. So if I just replace this with cases, cases, now the body of the function is just a pattern match. So we'll match on if it's a left bracket. Then what are we going to do? We're going to push it on, right?
Yeah.
Let's say push. Yeah. Cool. Why is that not liking that?
Well, cases right now is partial.
Oh, right. Okay.
It's saying, oh, you didn't take care of all of your cases.
Right. I'm gonna put this all in an inner function, and we'll talk
Yeah,
about
what
why.
if we extract some of this into some helper functions?
Okay.
Like, so if you give me a char,
Okay.
so if you are an open parens, true. If you are an open curly brace, true. If you are an open bracket, true. And any other case, false. You'll notice this question mark. This question mark is how we introduce a character literal. So this is a single character of open paren. And you can compare that with the text literal, which would look like that. But we're operating on the single character. So
I think we're gonna right away need a close. If close.
I think so. Here, I'll do that as well. Is close. And here I'm going to show the cases syntax actually, so you can see how similar they are. Okay, cool. So if it's open, we're going to push the character onto the stack. If it is a close, do you want me to write a is paired function?
Yeah, I
like
was
takes
yeah.
an open. Yeah.
Yep. That's right.
Paired takes in char and a char and returns a Boolean. Paired open close equals if. What's the best way to do it? Let's do a multi-pattern match actually. So that cases. I think that's basically it. This needs to be a comma. This also needs to be a comma. Okay, so if the open one is closed, return true. Otherwise, if you see any other pair of characters, return false.
Okay.
And we're going to call this paired. So we should probably handle the optional value here.
You are. Wait, how was that happen? Okay. We can handle it. We can handle it in our function.
Ah, that's a good idea. Okay. I could express this in terms of abort.
Sure. Yeah, go for it. So what we're doing here, for those that are following along, is that we wrote this inner function go. And the do here makes it a delayed computation. So that says don't actually evaluate this right now. Someone needs to pass a unit value to this to kind of start it going. But what that allowed us to do is allowed it to then use some abilities, because you can't just evaluate abilities at the top level. So this one, let's write it. We don't have to, but I'll write a type signature just to make it easier to understand. Go is really a function that goes from unit and can use the abort ability to produce a unit. So what it's going to do is it's going to scan across the list, and if it ever sees a problem, it's going to call abort, and if not, it's just going to do nothing. So what we'll do is we'll run this function under our handler that's watching for an abort, and if it sees an abort, we're going to return a false, and if not, if we don't see an abort, we'll return a true.
Yeah, and I just realized I think that this function doesn't need abort because it captures if the none case is none here, it'll just return
Well,
false.
you could also just
So
change
I
it.
think we're good.
You could change it to abort unit as well. That's actually, I think, it would be even better. instead of returning true.
Oh, interesting.
So these can all just become and this can
Those are
become
unit, and this is abort.
yeah.
I got it.
This is not a sum tuple, right? This is the first one's a sum.
No, it's not a tuple. Just the
Oh,
first one is the sum. It's confusing because the
wait, the parentheses.
it's
The
confusing
parentheses.
because this.
Something's
Yeah.
not right. Yeah. Okay, I got you.
Okay. Cool.
Yeah, that's really hard to read because we're not taking breaks. All right, so let's handle our actual abort now. I'm going to go to the bottom of the function, and so there's a couple ways we could do this. We could turn it into an optional, or we could just handle it. So we could say handle go. We'll talk about the syntax in a second with a pattern match. Oops. And our two possible patterns are that they called abort. If they did, we don't really care about the continuation because no one's going to continue. We return a false. And if they never called anything, they just returned a value, which we know that to be a unit, but we don't care what it is. We know it's a unit. But in that case, we return true. Okay.
Okay.
We got a problem on line 37.
Let's take a look.
Right.
Paired.
We just need to call paired peak, and that's it. It'll abort for a moment.
Paired pink.
Right.
Okay. Very cool. Let's just double check.
It needs the what?
Expression in red needs. So this is a great error. So what this is saying is you've written a function called go. Go, you said it has access to the abort ability, but we're also calling these stack operations in the go function here, and we didn't add it to our ability requirement list here. So let's go ahead and add that here.
Right. There you go.
There, and let's resave the file. Let's see. Okay, cool. So it looks like things are type checking, which is awesome. So one of the really awesome things about Unison is you can't save non-type checking code to your code base. So the process of compilation is like the bar for adding code to your code base. So you can't check in weird, malformed, non-compiling code.
All right, so I want to talk about a few little quick matters of syntax while we're here. What's first on line 30? Mm-hmm. Just because I wrote it in a way that's probably easier for people to understand, is that this is a function that takes a unit value, which is the way it's delayed. Because you can only really attach these ability declarations onto an arrow. They have to be part of the function call. So as the Unison syntax, this is the same syntax as this. We can put a little tick there and leave off the and that's just Unison syntax you'll see all the time. And then similarly, if we go down to where we call our function on line 65, here you see me actually explicitly passing the unit value in to make the compilation to undelay the delayed compilation. And another bit of Unison syntax that you'll see is that's the same as putting an exclamation point in the front, which is a signifier to run the delayed computation. All right.
Yeah. Thanks for calling that out.
Sure.
That's a good thing to remember. Is delayed computation syntax comes up over and over again. So remember, the bang operator forces the thunk. The single quote is a delayed computation, which is the same as a function with no arguments to some type.
One argument of type unit.
Yeah,
unit.
Yeah.
Have to pass anything. All right, we have one function left.
Yes, so this is actually where we call the stackability handler that we wrote.
Right.
So first we want to change this input into a char list, probably. So to char list of input.
You know what? Let's do it. Since we haven't used it yet, here's another bit of kind of idiomatic way that you'll find people writing. Maybe we'll write it like a kind of a chain of events that's going to happen to the.
Ooh, yeah.
Okay, so we're going to take our input. First, we're going to turn it into a char list. And then what are we doing? You got it.
Okay, so then we want to take our char list and we want to run it. We want to run our, what is it called? Check balance function. And stack.run takes a delayed computation, doesn't it?
It's going to have to, yeah.
Yeah, it does. Yeah. Okay.
So check balance needs to take, oh, right. No. Oh, sorry. I'm messing it up, I think. Is that going to work? Okay. Great. How do you got it?
Okay.
Okay.
I mean, LSP is okay. Cool. So,
Can we load our tests?
should I add it? Do we feel?
Yeah, we can add
Yeah, let's load our test, actually. Load matching brackets .test.u. I could not find, oh, you know what? I do need to add this first if I'm loading it. So I'm going to add that. Okay. And here we have the expression in red needs the stack char ability, but this location does not have access to any abilities. Interesting.
Wait, where?
I wonder if...
Where is that? I'm sorry.
I wonder if how... So this is when we load the test. This is actually...
Oh, okay.
In the test.
Oh,
So I think how we've called this stack.run is not quite right.
No, it's not. Because here, I think...
Yeah.
I mean, yeah, maybe it's... I mean, it's going to be... It's earlier. There's a list, and what are we doing with it? We're going to run stack.run on delayed computation with the lists.
Yeah. With the delayed computations, the sort of like passing the argument style via the pipes can get a little thorny. So
didn't work out that way, but this.
Yeah. Okay. But now this is great. So what I did here is I set it with this type signature is I was like, I'm not sure that we're actually eliminating the stackability, right? That's what the error was kind of indicating.
Yeah.
So to double check that, I added this ability requirements list of empty list. So this should be a pure function by the time that this is called. And now it type checks, which is awesome. So I can update it. And now if I reload the test, let's see what happens. Okay. So let's see, did these pass? Ooh, it's evaluating the watch expression. And it's not done. So I think we might have do we have a little loop issue?
No.
Maybe.
Oh. Okay.
Oh no, it was just less hanging out for a second. Okay. Well, it looks like we've got some failed tests, so let's look at unpaired brackets first, yeah?
Yeah.
Let's go over here. And I'm actually just going to copy this over to a watch expression.
I know what the problem is.
And we can kind of...
The problem
what is the problem?
We have to remember to check if the stack's empty at the end.
We also need to do that. Yes, we should do that. Okay, so
I think
that should happen.
We need to
right
do that.
after
We'll do that with an
go.
abort, so we want to do it after the for each, I think.
After the for... okay.
Yeah, wait. I think it's, yeah.
Is that right?
Right
Right here?
Yep, I think so.
Stack.is empty. So if stack is empty, then unit.
Yep, do nothing else.
Abort. Okay, and let's double check. Am I? Oh, I'm still in the for each. That's my bad. I gotta move one out
Oh, yeah.
and fix my indentations.
It needs to be equal to 40. Go in two more. Yep.
And two more.
All right.
Okay. Okay. So I'm gonna update that. And let's reload our tests. Okay. And now a slightly different set has failed.
All right.
So now paired square brackets is now failing. Let's take a look at that one. So this is our happy path case.
Haha. You know what? We need to. Oh no. I don't know. I don't know. I thought I had an idea.
I think that we are forgetting to pop something off the stack, specifically after
You never pop.
we have identified. Yeah, we got to pop something.
It's it. Yep. There you go. You're right.
Okay. Okay, let's try update. And let's load the tests and get another press. And oh, look at that! We did it!
Virtual
Okay.
with your non-camera thing.
Virtual high five. I know. You can't see me, but I'm definitely doing that.
Okay, so we should definitely show how.
Okay.
Should we show how we can submit these, or is there? I guess that's.
Yeah. Yeah, it's pretty simple. So what we do is we go back to this normal terminal, not the UCM console, and the Exercism command line. It's like a submit command. I gotta look it up because sometimes I forget it. Okay, it's Exercism submit and then the file path. So we want to go matching brackets and we want to submit matching brackets.u. Okay, and that should submit that to the track runner.
Great.
Which is viewable in the web. So, and then, we failed our iteration test, but I think that may be a timeout issue for the test. But we see our implementation here, and this is what we have submitted. And yeah, and that's our, is this the right one? Yeah, that's correct. Okay.
Yep.
Okay, awesome. Yes, if you're seeing some timeouts in the submission process, give me a heads up. Ping the help channel. We are seeing a couple of timeouts just with our Exercism test runner, but it does not reflect on your code. It's probably just a timeout issue. So, yeah, I'm back.
Great.
Cool. Do we have any questions? Are we good in the Twitch chat?
I think Paul and Cody have been answering lots of questions. I haven't seen any questions.
Yes. Well, folks, stay tuned for tomorrow because I think Unison co-founder Runar Bjarnason is going to do an implementation of the zebra puzzle, which I have looked at the community solutions for, and precious few people have done it. So if you're stuck on something, be sure to tune into that one because I think it'll be really fun. And he might even do some sort of like each ability, so more abilities. Or constraint solving. So I think that'll be a really cool thing to watch.
Yeah, for sure.
But yeah, hopefully this has been useful. If folks want to give Unison a try, we're really friendly. We try and be really welcoming. So
Yeah, come
always give us a shout out.
Slack. We have a beginner-friendly channel, which is a great place to introduce yourself and ask easy questions that probably other people have and aren't too afraid to ask. So please come join us.
Yeah, there's no such thing as a silly question because we know, as we're making a really different language, we have to be extra, sensitive to the fact that like it's new and it's hard and, there are new patterns that we're trying to establish. So yeah,
And
come
also,
give us a follow.
we will be doing more live streams on this channel, but normally this is for Rebecca and I, we do this almost every Wednesday at the same exact time. So even after the mind shifting May has ended, if you are still interested in checking us out, the two of us do this kind of pair programming in Unison most Wednesdays. So hope to see you there.
Yeah. Yeah. Awesome. Well, thanks so much, Stu. This was really fun.
That was fun. Thanks, Rebecca.
Yeah. See you next Wednesday.
Bye.
Bye.